All right, guys, today we're going to talk about inscribed angles. Inscribed angles are angles whose vertex is actually on the edge of the circle. I know if you look under the vocabulary, the way they describe it, an angle whose vertex is on the circle, I like that. But then it said, and whose sides contain chords of the circle. That's true, but I just think if you just focus on the fact that the vertex is actually on the circle, that would be enough. So if you look over here to the right, you see that vertex is that little red dot. It's actually on the edge of the circle. That makes that an inscribed angle. So the angle is actually, you'd measure it right here. And that angle is doing what's called intercepting an arc. And so the arc that lies between the two sides of that angle, of course, the blue lines are the sides of the angle. The arc that lies between them is right here. That's called your intercepted arc. Subtend is another vocabulary word that you might hear once in a while. I don't tend to use it, but it's when a quarter arc's endpoints lie on the sides of an angle. So I use the words intercepted arc and inscribed angle, and I don't usually use that word subtend. But it was in the book, so I guess I included it in these notes. All right, the important thing about inscribed angles and their intercepted arcs is they have this kind of 2-to-1 or 1/2 relationship. The angle will always be smaller. So think about when we were doing central angles. When we were doing central angles, this angle had its vertex at the center of the circle, not on the edge of the circle. And a central angle was intercepting this kind of highlighted arc here where I'm highlighting. And the relationship was they were exactly the same. The angle would measure exactly the same as the arc. So if the angle was 60, the arc was 60. That's not the case with inscribed angles. With inscribed angles, when the vertex is on the edge of the circle, the relationship is the angle will be 1/2 the measure of the arc. So if this arc right here in this first case 1 was 60, that would mean the angle would not be 60. The angle would be half that. It would be 30. So that's the difference with inscribed angles and central angles. So in this box, it says your angle in these pictures, and they drew the angle a couple of different ways. There's really nothing really terribly different about them. What I want you to focus on in each of these cases is that the vertex B is on the edge of the circle. And the reason they just drew 3 different cases is sometimes one of the sides of the angle could go right through the center, which means it would be the diameter. It could kind of surround the center, or it could be above or below the center. So it could look kind of different, but the important part is the vertex B is on the edge of the circle. So again, your angle will equal half of your arc, and that's what the box that I circled says, or boxed. So angle equals half of arc. And anytime you have a fraction in an equation, you could also multiply both sides by 2, right? And state it a different way. That means you could double the angle to get to the arc. So to me, it just depends which thing is unknown. Is it the angle that's unknown, or is it the arc that's unknown? If the angle's unknown, I'm going to take half the arc. But if the arc's unknown, I'm going to double the angle. So when we come down here to example 1A, the thing that's unknown is the angle. You can see a little question mark down there, right? They put a little question mark down there. I like to change that to an X, all right? So the thing that's unknown is the angle. The arc that the angle is intercepting is right up here, and so I know the arc. So for this one, I would use the relationship that angle equals half of arc, because that's my X is my angle, and I can just take half of 146. And X would then equal 73 degrees. All right. Example 1B. In this case, the thing that's unknown is the actual arc. You can see that question mark, which I'm going to change to an X. This measure is what they're looking for. But they gave me the 80, right? They already gave me the angle. So in this case, I would use the relationship that if I want to know the arc, I can just double the angle. And so my arc is X. If I double the angle, I get 2 times 80. And so my X in this case would be 160. So I'm really using the same formula. It's just which word am I isolating? Am I isolating the arc, or am I isolating the angle? And it just depends what's unknown in your picture. All right, example 1C throws a little bit of a twist in there because the angle is that angle Q over there with the question mark. The arc it's intercepting is SR. Well, I can't have two unknowns. I don't know anything about SR, so I can't solve an equation that has two unknowns. So I got to figure something out here. I have to put a number either for X or for SR. Well, if you look at the circle, there's 126 on the edge, there's an 80. Well, the only piece that's missing then is this red piece. And I know a full circle adds to 360. So 360 minus the 126 minus the 80 will give me 154. So I know that red arc that I highlighted is actually 154 degrees. So now if I want to get the angle, I can take half of the arc, and I now know the arc. So this is one of those kind of puzzly ones. I have to figure one piece out before I can actually write the equation. So 1/2 of 154, because I'm taking half of the arc, and so my X will equal 77. All right, so just a little bit of a twist on that one. The only other thing we could really do on these type of problems is throw in those variables. You know, we like to throw in algebra once in a while. So we're throwing algebraic expressions on the edge of the circle. But the relationship that we're going to use is the same. We're either going to say the angle equals half the arc, or the arc equals double the angle. And so I always ask myself, where's the variable? The variable is on the arc, right? So I like to use arc equals half of angle. So I do that because the variable is on the arc. And so I'm going to just keep that word arc isolated. My arc is 10x plus 2. That's equal to half of 36. If I take half of 36, I'm going to get 18. I have something wrong here. My bad. I am sorry. I'm using the wrong thing. I wrote the wrong thing. Arc is equal to double the angle, not half of it. Sorry, that was bad. So my arc is 10x plus 2, and it will be double your 36. So the arc is always bigger than the angle when you have an inscribed angle. So we'll have 10x plus 2 equals 72. Subtract the 2. We'll get 10x equals 70. And in this case, x equals 7. All right. The difference between A and B in example 2 is the variable is now back on the angle. And so in that case, I like to keep the word angle alone because that's where the variable is. And then I'll use angle equals half of arc. So 13x minus 4 equals half of 122. So 13x minus 4 equals 61. Add 4 to both sides. 13x equals 65. Divide by 13, your x will equal 5. Okay? So again, it just depends where your variable is, the way you might want to use the formulas. And it certainly wouldn't be wrong if you wanted to do this problem and just say, I'm just going to double the angle to get to the arc. You could certainly double 13x minus 4. You could certainly double that and set that equal to the arc. And you could wow, what am I writing there? You could distribute and solve it, and you'd still get x equals 5. So you can use the formula either way. You don't have to use it the way I'm showing. Either way will work. All right, the reason I put C in there is because there are variables on both the angle and the arc. And so, again, it just depends. Do you want to take half of your arc? Well, you'd be taking half of 11x minus 11, which is fine. You'd have some decimals. It wouldn't be that big of a deal. They'd be nice, clean decimals. But in the effort to avoid decimals, what I'm going to use is arc equals double my angle. Because if I double 5x, I don't create decimals. If I take half of 11x minus 11, I do. So that's the only reason I'm using the formula this way. Arc equals double the angle. You can certainly use decimals and use the angle equals half arc. That would work too. So my arc is 11x minus 11. I'm going to double my angle, so I'm going to double 5x. 11x minus 11 equals 10x. And if I subtract 10x, or you could subtract the 11x, whatever you want, no matter which way you do it, you're going to end up with x equals 11. So I subtract 10x in my head and I get 1x, but then I moved the 11 to the other side and it turned positive. But you do the algebra how you like to do it. All right, the final example is another one of those kind of puzzly problems. And that's because the arc that 82 is intercepting is right here. And I don't know anything about it, but I know everything about the rest of the circle. However, before we did 360 minus to get to this missing piece, but we really don't want to subtract an expression that has a variable. So that would work. It's just not the easiest way to do it. So the way I would recommend doing it is if you know that your angle is 82, right? You know this angle is 82. If you double that, you will get to the arc. So the arc is going to be equal to 2 times 82, which is 164. And now I know everything about the outside of the circle. One piece is 134, one piece is 6x plus 2. Actually, let me kind of highlight those in different colors so you see what I mean. You know this piece is 132. You know this piece right here is 6x plus 2. And you actually now know that the red piece is 164. And anytime you know everything about the outside of a circle, you should know it adds up to 360. So we'll have 6x plus 2 plus the 134 plus the 164 is going to equal 360, which means 6x plus 300 equals 360. Subtract the 300 from both sides, you get 6x equals 60, and divide by 6, your x equals 10. All right, so that one was a bit of a puzzle. You had to kind of think about what could you do with that 82 that would help you out. All right, hope this helps.